14 through 17, and I'm just going to do the problems that I had assigned to you today in class, which was a shortened amount. You can look at the key here and look at the rest, and then ask me in class tomorrow if you want to know the answers to the other part. Okay, so number one, you want all 8 of these drugs to be effective with a 70% chance of being effective. That means all 8 of them are of the 70% that are effective. So when you do 0.7 to the 8th power, you end up with 5.76%. Remember that at least 1 is 1 minus the probability that none of the 4 cases are effective. Okay, so that's this here, 1 minus 0.3, because that's the not effective to the 4th power. So this part is all 4 of them not being effective. So that's 99.2%. Now, the other way you actually could do this problem, if you think of it this way, is that you want to have an effective case in spots 1 to up to 4. And so that's geometric CDF of 0.7 to 4. So you want it to be in any of these 4 spots, the effectiveness to occur. All right, so there's 2 ways to do that, whichever way you like is good. Number 2, and I do know that there is one almost identical to this on the test that people struggled with, okay? So let's just really make sure that you follow this problem. You have a group of 14 members, including 9 college graduates, 4 are women, and 5 are people who did not graduate from college, of which 2 are women, okay? So I don't know, I kind of used a picture to help organize that for me. I have 14. Here is the 9 up here that are college. Here's the college graduates in this top section. And then here's the males and the females. 5 are males, 4 are women. And then not college graduates, 3 are males, because I know that 2 did not graduate from college. 2 of the women did not graduate from college. That makes the other 3 that did not graduate from college men. So that's kind of the way that I organize this. So if the chairperson is randomly selected, find the probability of getting a woman. Well, that's just straight up 6 out of 14, because you're just going to get a woman. Now, if the chairperson is randomly selected, find the probability of getting a man or a college graduate. Okay, so you could talk about this here. You could look at the picture, and a man or a college graduate comes from these pieces. Here's the men, and then there's the women portion, that's the college graduate. So you could add these sections together and get 12 out of 14. Otherwise, you could have maybe used the formula, which overall probability of man is, there's 8 of them, plus all of the college graduates, which is 9, but take away any part that is double counted, which is the 5 that are the college men. Now, this piece right here, by the way, this is on your formula chart. It is the top problem on the probability portion of the formula chart. I'll show you where that is just really quickly. Okay, so you know, you can either draw yourself a picture for that, or you can take a look at the formula chart. Either way, okay, but here's where that is on the formula chart. It is this one right here. See, I did the probability of college plus the probability of man minus the overlap that got double counted, which was college and man. All right, next, C, 2 members are picked randomly for a special project. Find the probability that they are both women. Well, you cannot have the same woman, so when you pick, you have to have 2 separate women, so it has to be 6 over 14 times 5 over 13, and that makes 16 and a half women. At each meeting, one of the 14 members is randomly chosen to be a secretary. Find the probability that the first 2 secretaries are both men. So the first time and the second time. Now, because it says a person may be selected more than once, that means the first time the probability of it being a man is 8 out of 14. And the second time the probability of it being a man is 8 out of 14. So that's the two secretaries that they have, maybe 1 year after the other, or I guess meetings. So one meeting and then the second meeting. All right. You did not do 3 or 4, but you could pause the video and look at those answers really quick and see if you have any questions on those, but there's the answers. All right, you did not do 5, 6, or 7. And so I'll let you look at those videos, or you could pause the video right now and look at those answers for 5, 6, and 7. All right, so let's go on to 8. Okay, number 8 is the pizza, the type of crust, and then the type of pizza that it is. What's the probability of selecting a thin crust pizza? So this one's going to be similar to the tourism and the Isabella, the place, the the uh, job that you went into and the island that you came from on the Galapagos Island problem review that I just went over. So here we have type of pizza and the crust. What's the probability of randomly selecting a thin crust pizza? That's just thin overall, so you had to get those totals. Thin overall was your 55 out of 117. What's the probability of randomly selecting a supreme? So that's supreme overall, so that's your 42 over your 117. Now, what's the probability? This is the ones that people struggle with. What's the probability of randomly selecting a thin crust pizza given that it is a meat lovers? Do you see this? Given that it is meat lovers. So out of all of the meat lovers, which is 44, so out of all of these meat lovers, the portion of those 44 meat lovers that are thin crust is 16. So 16 over 44 is how you get your 36.7%. Now the next part is again that test for independence. You have to know how to do this. So I'm going to show you very clearly that first find an overall. So I'm going to pick one of them and I'm going to say the probability of thick and whatever that was, which then I need to go the probability of thick and then put a given that. Given that it was supreme. So did this change? The fact that it's supreme, did it change these probabilities? Okay, so the numbers that I had gotten on the front for that, overall thick was 62 out of 117. The other was 18 over 42. Let's see if I can transfer that. 62 over 117. And then the other one was 18 over 42. So, well, here you can see that we got 0.429 for the, given that it's supreme. So 0.429. And then this one was 0.530. So here is how you summarize that. Given that you have a supreme type pizza, you are what? You are less likely to have chosen a thick crust than thick crust overall. I'm going to say that one more time. Given that, this is where you start. Given that you have chosen a supreme pizza, you are less likely, going from 50 to 43%, to have chosen thick crust than thick crust overall. Therefore, they are not independent. Your choice of pizza is changing the rate at which you chose thick pizza. All right, on this Venn diagram, remember that I told you you have to start with the most strict category. So in this case, the one that has 3. So I can see that I've got the sports, the walking, and the lifting weights, and this is where I would start. 7% walk, play a sport, and lift weights. So that's where I started. All right, then I would go to ones that have 2 things. So I see here 16% play a sport and walk. Okay, so that means this little football region right here totals 16%, of which 7% is already in there. Therefore, the remaining is 9. Okay, then I'm going to do this one here. 15% walk and lift weights. So if I go to the walk and lift weights little football here, 7 is already accounted for. Therefore, the remaining 8% is what totals up to 15% that walk and lift weights. Then, let's see, let me go ahead and fill in this. I like the little only ones. Those are also pretty straightforward. 6% only lift weights. So, see, I can put that here in the only category. So, now, what we can do is go from there, and it says, let's see, 25% lift weights. All right, well, then that means this entire weight circle that I'm looking at is supposed to total 25%. Well, I have already got 7 plus 8 is 15, plus 6 is 21, so I have 21% in there already. Therefore, the missing box or the missing section is 4%. Now, weight is completely filled in. Okay, now let's go to this play a sport. 36% play a sport. That is this entire circle right here. 36% play a sport. Well, I have 3 parts already. 9 plus 7 is 16. Plus 4 makes 20. Therefore, in order for this to be 36, I need to add this other 16% to be a total of 36% playing a sport. And finally, the 57% that walk. So for the exact same reason, I have this entire circle is 57%, of which 9, 7, and 8 are already in there. That's 24. Therefore, the remaining part to total up to 57 is 33. Now, add up all of those little bitty spaces and then subtract that from 100% to get the portion that do none of those items. And that is how you fill out the complete thing. So let's see, do we have questions then that go along with that? Okay, so straight up, does not lift weights, walk, or play. That is that 17% on the outside. Only walks, that's that 33% that we found in the circle that only walks, plays a sport, and lift weights. Play a sport and lift weights. Let's see, where did that go? Aha, that's this section here. Plays a sports and lift weights, which is 7 plus 4%, so that's a total of 11%. That is how you get that. All right, so finished with number 9 and number 10. Number 10 is a survey. I like this one because it's got 2 of the given type problems. You have got to know how to do those. A survey is conducted to determine whether any relationship exists between the level of education and the local residents. A random sample of 500 people produced the results down there in this table. Find this situation here. Lives in a rural area given that they have a college education. So out of all of the college education people, which is 193, what portion of that are from a rural area? 13. Next, has a secondary education given that they live in the suburbs. So that would be out of this 244. Hold on a second. Up. I went the wrong way on that. Okay, see, this one is given that they are from the suburbs. So I need to do the suburbs category. Is this 197? And of this 197, 118 is the secondary portion of this 197. All right, so that's 59.9%. Now, had this asked for independence or question for independence, here is maybe something that you would have checked. It did not ask for that, but you would have done something like this. Oh, I'm going to say probability of urban overall. And then you fix that, you find that, which was 197 out of 500, okay? And then I say, okay, well, let's check this urban and say, given college, see if that has now changed. And so that is going to be in this section. So out of the 193 that went to college, the urban portion of that is 111, and you check to see if this conditional probability is the same as the overall probability, and then that is how you check your independence. And so given that you've gone to college, the fact that you've gone to college makes you, I don't know, more or less likely to have done the other thing. Okay, you also did 11 and 12. 11 is about combining means and combining standard deviations. All right, so the means combine like you would normally expect them to, but the standard deviations do not. These standard deviations, in order to combine standard deviations, you cannot just add them. They have to go through the Pythagorean theorem of statistics, and you get 228.03. All right, 12 is another normal problem, and since this is talking about the top 18%, that is where I'm going to get a z-score. So I know that the mean is told to me to be 150. The standard deviation is told to me to be 12. And the question is, what is the candidate's score? That is an unknown x. Now, the z-score is also unknown, but you can find it from this top 18%. And you know that you have to do inverse norm of the area below, inverse norm of the area below, inverse norm of the area below. Is that z at that spot? And that area below is 82%. So inverse norm of 0.82 is 0.9153. Now I have 3 out of the 4 items, and I will fill out the z-score formula and solve algebraically for x. So this is going to be, 161 points. That would be the minimum if they're in whole point values. All right, 13a is also a normal curve problem. It is between two x values. So I wanted to remind you how to do that. You have a mean of 84. Well, guess what? When you have a mean of 84 and it wants to know from that value the area between this x score of 84.5 and this x score of 90. You need to find a z-score for both of those x values. The z-score for this mean is 0. The z-score for the x value of 90 is 0.7051. So now find probability, find the proportion of observations. When you find percentage, you're not done until you have used norm CDF from low z to high z. So my low z is is 0. My high z is 0.7051. So I put that into my calculator, norm CDF from 0 to 0.7051, and I get 25.96%. And then you also did E. E is also between two z-scores. Yes, well, z-scores, but they are an x value of 75 and an x value of 80. So I wanted you to practice that again. The z-score for the first x value is negative 1.2179. The z-score for the second x value is negative 0.5769. And find probability, find the proportion of observations. When you find percentage, here in between those two z-scores and those two x values, use norm CDF from your low z to high z. And that gives you 17.04%. All right, number 14. Okay, this is, again, another normal problem because I kind of had to give you quite a bit of review. We hadn't done these in a while. The deal is that it tells you the mean of 150. It tells you the standard deviation of 12. You do not know the x value, but the z-score comes from inverse norm of the area below, inverse norm of the area below, which is 20%. And so inverse norm of this area below is negative 0.8416. All right, so now if you take this right here and you solve algebraically into this equation for x, you get about 140 points on the next test, assuming that they're in whole number points. Okay, here is the problems 15 and 16. If you want to do those, I'll pause that right there so that you can take a look at those and those answers. I'm not going over them, but there's what they are. Here are the answers to problem number 17. Pause that right there if you want to look at that and do those problems. And now let's go to number 20. Oh, here's the rest, sorry, of 17 up there. Oh, hold on a second. Let me go to 18. It looks like I skipped. Ah, there we go. Oh, 18, 17 was that little bitty D there. Okay, sorry. 18. This is very similar to the one on the front page where you had to fill in this missing percentage, because you know that the entire probability of this line should total up to 100%. So that was a value of 1. So that is how you can find what is missing. And so getting at least 3, you're just going to take this and add those probabilities together. What's the probability that a person does not get 1 correct? Okay, that means the person does not get 1 correct. That means, let's see here. 1 minus the probability of getting exactly 1. So there's really kind of like 2 ways you could interpret this one. So here's kind of the ways. If you say what's the probability that a person does not get 1, if you interpret it as 1 minus the probability of getting exactly 1, meaning does everything except for that 1 right there, then you're going to do 1 minus 0.151 to get your 84.9%. Okay? Now, I think probably the more likely way that this problem was intended is you do not get any of, 1 minus the probability of getting at least 1 correct. So, in other words, all of them are wrong. And so then that is 0 of them correct, and that would be 0.028. 0 of them are correct. Okay? So, either one of those is correct. All right, and D, what is meant, or what is the mean of the distribution? Okay, and the standard deviation. So that comes from that horrible, horrible formula, or you go do that little nifty trick where you put list 1 is 0, 1, 2, 3, 4, 5. List 2 is the probabilities that go with that. And so I'm going to pause for a second and put that into list 1 and list 2 into stat edit of my calculator. Okay, I put these into the stat edit of my calculator. Now I go to stat, over to calc, one variable stats of the list 1. So if you have your stat wizard, then the first thing you put right here is L1, so second 1. And then with list 2's frequency. So if you have stat wizard, go to the next line and put list 2. For those of you who have this, put a comma and then second 2. So one variable stats L1, comma, L2's frequency, and then you compute that. So then up here on the top, X bar is the mean of X, and the standard deviation is 1.11. So that is how you find that mean and the standard deviation of that distribution. All right. So let's see, number 19. This one was just writing down a table from the information given to you. A contractor has 80% probability of making $70,000, 15% chance of losing $20,000, and 5% of breaking even. What is the expected value? So you had to make your little table here first, where this first line is your profit, and the second line is the probability of those profits occurring. Making $70,000, of course, is a positive $70,000 at 80% chance. Losing $20,000 is negative $20,000 with 0.15, and breaking even is a profit of 0, and that's a 5% chance. So I went and put those into my calculator, or you could just go ahead and do your 70,000 times 0.80 plus 0 times 0.05 plus negative 20,000 times 0.15, and that's how you get an expected value of breaking even of 53,000. Okay? All right. Next, 20. Premature babies are born more than 3 weeks early. So that would be the definition. Newsweek reports that 10% of live births in this country are premature. Suppose that 350 live births are randomly selected. So they are premature or they are not. Okay, and one birth, I would imagine, is independent of the other. Probability is staying the same. So more than, so purely more than 50. That is going to be using 51 plus dot 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 plus all the way up to 350. So this is a more than, therefore you want 51 to 350, but your calculator does not have the ability to accumulate 51 to 350. So in order to do that, you have to do 100% and take away the bottom portion that is accumulated. So since you want purely more than 50, you want to take off the bottom 50 this time. This time it didn't say at least 50. It says purely more than. So you want 51 to 350. So 1 minus binomial CDF of 350, comma, 0.10, comma, 50, and that gives you 0.426%. What's the probability that exactly 40? So you fill out the formula. This is a binomial PDF because it is in particular exactly 40. What's the probability that not more than 25? So I do not want more than 25. It helps me to think, okay, I don't want the 26 to 350. Okay. The calculator will accumulate from the bottom, and I want 0 up to 25. So the calculator will do the correct accumulation for me when I just do straight binomial CDF 350, comma, 0.10 up to and including 25. Notice your work is this way. 350, choose 0 plus dot dot dot. 350, choose 25. That ends up being 4.5%. How many babies would you expect? This is straight from the formula chart right here. This is coming from how many would you expect? And here's how many, there's the formula for expecting with this standard deviation. Of course, here's your binomial formula if you needed to look at that to fill in your work. And so I just multiplied. I got 35 babies. The standard deviation is 5.612. And F, use that information in parts D and E. And now let's do a normal approximation. Probability of having 50 births are premature. And here we're using the normal approximation. So I'm using mean is 35. Standard deviation is 5.61. I do a z-score. My z-score is 2.6726. And since I am finding the probability, find the proportion of observations, finding this percentage, use norm CDF from low z to high z. And again, I'm going out to positive infinity since it is a more than problem. That comes out to 0.376%. All right. Let's see, you did not do 21 or 22, so I'll show this here so that you could stop and do that problem if you needed to. 22, here is the answers for that. That again is also just another one of those find the expected value. All right, and here comes 23. You just remember that if you know how you perform on one test and you know how you perform on the other test. Well, they had different means and different standard deviations, okay? So in order to compare one test to the other, you have to compare your z-score. And so if you can compare your z-score, the one that you are higher up from the mean. So this guy was 0.554, half of a standard deviation up for test 1, and a higher up, 0.6173 standard deviations up for the second test. So test 2 was, he did better because it was more standard deviations higher. A z-score is how many standard deviations you were up. You were more standard, you were 60% of a standard deviation up and 50 versus 54% of a standard deviation up. All right. This last one, number 24, is a big one here. So let's make sure we've got this down. You first have got to set out your tree diagram. I knew I needed a tree diagram because it says, if you did the SAT, then this happened. If you did not take the SAT course, then this happened, okay? If this, then that. But if this, then that. So because there were several if this, then that's, I thought I need to do a tree diagram. So 5% of the students took the SAT course. That's the SAT prep course, all right? And of those, see, if you did that, then 30% got admitted to their first choice. Now, if you did not go to the SAT course, then that's 95%, see? And so then it says, let's see, 20% of the other students got admitted to their first choice. So there is how you got admitted to your first choice. So the way you get admitted to your first choice is 0.05 times 0.3. And whatever that is, here it's 0.95 times 0.20 or 2, and whatever that is. So that is your ways to get admitted to your first choice. So out of all of the ways that you are admitted to your first choice, and I'm kind of actually jumping ahead. We haven't read the question yet. Let's do that so we know why I'm getting these numbers here. The question says, you overhear a classmate say he got into the college he wanted. So that's a given. So given that he got into the college that he wanted, that's this right here. Given that, that goes on the bottom. So that's all of those students who got their first choice. What portion of those did not take the test prep class? That's what this was asking. What's the probability that he did not take the SAT prep course? All right, so given that he got into his first choice, what's the probability that he did not do the SAT? So this is the portion that did not do the prep course. So that 0.19 over 0.205, 92.7% chance that he did not take the SAT prep class, given that he got into his first choice. All right, so that is it. And I also showed you the other ones along the way, even though I didn't explain those, but you can see those and then be prepared to ask questions tomorrow.